a washer dryer. That's a combination. So it has a tilt drum inside. It's at a little bit of an angle, right? What does that do? What does that mean that it's at an angle? It's actually much more efficient. Here's the same depth of water, but it actually uses a much smaller volume of water to achieve that depth. With every wash, you'll actually save 20 gallons of water. Even more than that, you'll save the energy you would have used to heat that water. So it's incredibly more efficient. And that's just the washer part. In the dryer part, we use a heat pump to make it unbelievably more efficient. Now, heat pump works on the idea that if you compress a gas, it gets hot, and when you let it expand, it gets cool. So, would someone like to demonstrate? I've already made Brandon so somebody else is to step up. Randy? All right. You can monitor the temperature in this water bottle, and as Randy pumps air in there, he's going to compress this air, and the temperature rises. Now he's created all of this heat from compression. So you can use that to heat your home, or heat your hot water, or heat or dry your clothes. Wow, Randy works good at this. He's gotten it up, thank you. 81 degrees. Amazing. Now, when you release that pressure, chills out, literally. And you have this cold that you can use for an air conditioner, for your refrigerator, for your freezer, or even to dry your clothes. Because we actually use both sides of the heat pump in this machine. Okay, so you have wet clothes, and they're tumbling around in the dryer, which makes the air around them very moist. You have this humid air. You bring it down, and you pass it through the blue radiator. Now that is the cold side of the heat pump technology. It's wet, it's cold, it condenses, drips and drains away. Now you have dry, cold air. So you pass it past the red radiator, which is the hot side of the heat pump cycle. Now you have dry, warm air, and you can send that in to where your clothes are. Now you have wet clothes in a dry environment. It's going to be much easier, more efficient, and faster to evaporate the water into a dry environment than in a regular dryer where it's trying to superheat your clothes into evaporating water into a humid environment. So it's kinder on the clothes, it's faster, it's more efficient. The fabrics will actually last longer, and your clothes will look better. Well, once again, you've created very wet air. So you take this humid air, and you bring it back down and run it past the cold radiator. The water condenses away, and you have a constant new supply of dry air. Dry air goes to your clothes, wet condenses out the bottom. You notice it is a closed circle, which means there is no vent. So you don't have to put this on an exterior wall. You don't have to give up a window in your apartment just to vent your dryer. You can put it in your bathroom. You can put it in the kitchen. You can put it anywhere. You don't have to insulate the big hole in your house that is your vent. But in a regular dryer, because you've spent all of this energy, this electricity, this money to heat your air, and then you just send it out of your house. It's utterly useless to you. Sent out there, irritating the birds, making the icicles drip. Instead, you can contain the energy in a closed system. No more heat loss, no more energy loss. We're trying to eliminate heat waste. We've made a much more efficient dryer that is nicer to your clothes.